So welcome to lecture 4, question 1. So in this lecture 4, we are given a position vector r of t. Our r of t is 2t cos t, comma, sin squared t, comma, ln t plus 1. Ln t plus 1. These are position vector. Then we are asked to find the length L. How will you find the length? The arc length is given as the integral from a to b, the square root of d ds dt all square plus d dy dt all square plus differentiation of the z as is the z dt all square. So we need to differentiate each of x. This is x, this is y, and this is t. What's our x? Our x is 2t cos t. So we have to find the s dt. Our the s dt will be equals to, the ratio of this is t times cos t. Then the ratio of cos t is minus sin t, then times 2t. So minus 2t sin t. So this is the ratio of x. Now also we need to differentiate y. Our y is sin squared t, which can be written as sin t sin t. So we can use product rule. So dy dt now be equals to, the ratio of sine is cos, that's cos t sin t, plus, now we differentiate this, the ratio of sine is still cos, that's also cos t sin t. So we can add the two together. That means our dy dt is 2 sin t cos t. And in trig, we know that our 2 sin theta cos theta is equals to sin 2 theta. So we can use that to replace this. That means our 2 sin t cos t is sin 2t. So that means our dy dt is equals to sin 2t. So from there, also we need to find our z. Our z is equals to ln t plus 1. That means our dz dt be equals to, the integral of the differential of a ln is 1 over ln. So we are differentiating ln t is 1 over t. The differential of ln t, so this will be 1 over t plus 1. Then need to differentiate what is inside. The differential of t plus 1 is 1. If you differentiate t plus 1, you're going to get 2. So you multiply it with 1. So that means your dz dt is equals to 1 over 1 plus t. So we know our the s dt, dy dt, and the z dt. So we need to insert everything inside this equation. So let's take all of this off and insert that. So let's insert it. Our L now equals to the square root of the integral from a to b. Our a is 0. We are starting from 0 to 2 pi. The square root of the s dt all square. We got our ds dt to be equals to 2 cos t minus 2t sin t. Then we square it plus dy dt all square. We got our dy dt to be equals to 2 sin t cos t all square. Then our dz dt we got it to be 1 over t plus 1 all square. Then dt, to complete it, dt, when integrating with respect to t, so that's dt. So we've calculated the arc length of the curve of r of t. Now we have to use Simpson rule to evaluate this integral, and we have to use 4 subdivision. So that means for you to use 4 subdivision, so you have to divide from 0 to 2 pi by 4. So that's 2 pi, the maximum range minus the minimum range, divided by the 4 subdivision, so divided by 4. So you're going to have 2 pi over 4, which is pi over 2. That means each interval is pi over 2. The first interval will be the initial interval, which is 0. The second interval will be 0 plus pi over 2, which is pi over 2. The third interval will be pi over 2 plus pi over 2, which is pi. The fourth interval will be pi plus pi over 2, which is 3 pi over 2. And the last interval will be pi over 2, 3 pi over 2 plus pi over 2, which is 2 pi. So these are all the intervals we are going to use for our Simpson rule. And what does Simpson rule state? Simpson's rule. It states that if you are integrating any function from a to b of f of x, it's going to be h over 3 into brackets. We have 3 cases. That's f of, so you're going to have f of x naught plus f of x naught plus 4 f of x1 plus 2 f of x2 plus 4 f of x3 plus f of x4. So this is the Simpson rule, whereby our x naught is 0. This is our x naught. Our x1 is this. Our x2 is this. Our x3 is this. And our x4 is this. So we need to find what our f of x is. Our f of x is this. This is what we are integrating. So our f of x now, our f of x is equals to the root of 2 cos t minus 2t sin t all square plus sin 2t all square plus 1 over t plus 1 all square. So we need to find our f of 0. What is our f of 0? Our f of 0 is just putting 0 inside this function. So when you do that, you use your calculator. So you substitute your t to be 0 and see what you're going to get. So we do that, you're going to get root 5, which is 2.2361. So your f of 0 is 2.2361. How do you get that? You substitute 0 inside this function, you get this. Now you find f of x1 also, and your x1 is pi over 2, f of pi over 2. You substitute pi over 2 into this function to see what you're going to have. You're going to have 3.1656. So substitute pi over 2, which is 90, inside this function, but use pi over 2 directly. Use pi over 2 here. So you find f of pi, that's your s2, f of pi. You substitute pi. Note, when you want to do pi for this, don't use 90. You use normal pi, which is 22 over 7. You substitute as 22 over 7 here. But in this case, substitute as pi inside a function, or substitute as 90 degree, except you take it to radian. So leave it as pi inside your function and then calculate it. Your calculator will take care of the rest. So if you substitute as pi, you're going to have your f of pi to be equal to 2.0145. Then you find your f of x3, which is your 3 pi over 2, f of 3 pi over 2. You substitute 3 pi over 2 inside this your function again, and don't forget to square root. There's a square root. So you're going to get 9.4264. You find the last one, f of x4, which is f of 2 pi. You substitute 2 pi inside this function. You're going to get 2.00047. So we've gotten all our function, f of x0, f of x1, f of x2, f of x3, and f of x4. So the next thing is to substitute all these values into it. Now we need to know what our h is also. Our h in Simpson is b minus a over n, where your b is your higher division, your higher limit, which is 2 pi in this case. Your a is your lower limit, which is 0. And your n is the number of interval that you are dividing into 4 division, which is 4. So that is 2 pi over 4, which is pi over 2. So we've gotten our h also. So now we can substitute all of this. So that means our integral of a to b of f of x is now equals to h over 3, which is pi over 2 divided by 3. That's pi over 6 into f of x naught, which is the first one here, that's 2.2361 plus 4 into brackets f of x1, which is this one, 3.1656 plus 2 into f of x2, which is this, plus 2 into 2.0145 plus 4 into f of s3, which is this, plus 4 into 9.4264 plus the last one, f of x4, which is this, 2.0047. So you can calculate all of this using your calculator. You're going to get your L. You can press all of this in calculator. Pi over 6, pi is 22/7, then everything. You're going to get your sorry, not your L. You get your integral. The integral of is also your L, because the L is the integral of this, your L, because your L is actually the integral of this, which is what we went to do here. And we are going to have it as L to be equals to 30.7027. So we know our L already to be this, 30.7027. So if you know that, then we can calculate what we need, cos L over 3. So that will be cos, what's your L? 30.7027 over 3. Make sure that your calculator is in radian. You're going to get negative 0.69, which is this. So that's your answer. That's the answer. So we'll move to question 2 under lecture 4. So this is question 2 of lecture 4. We are given a particle position. This is the position of the particle, r of t, to be equals to 1 plus t raised to power 3 over 2, comma, 1 minus t raised to power 3 over 2, comma, 3t raised to power 3 over 2. This is the position of that particle. We are told that the position starts from 0, and when it gets to, this is your initial position and this is your final position. When it gets to t, the arc length it has moved, the L, is 10. It has moved this L to be 10. So we are looking for this t. And what's our arc length? Our arc length is given as the square root of the integral from a to b, the square root of the s dt all square plus the y dt all square plus the z dt all square, everything integrated with respect to dt. So we know our arc length formula. We know our L already. Our A is 0, our B is t. This is the t we are looking for. So let's find the s dt first. What's our x? This is our x, this is our y, and this is our t. So our x is 1 plus t raised to power 3 over 2. So what's the s dt? The s dt now will be, integrate this normally, that will be, differentiate this normally, that will be 3 over 2, then 1 plus t, then subtract 1 from here, that's 1 over 2, times, differentiate what is inside, that's 1. 1 plus t, we differentiate it, you still get 1. So that means our ds dt is just 3 over 2 square root of 1 plus t. So what's our y? Our y is 1 minus t raised to power 3 over 2. That's 1 minus t raised to power 3 over 2. So we need to find the y dt. The same procedure, your dy dt now. Differentiate this as if this is just x raised to power 3 over 2. So this will be 3 over 2 into brackets 1 minus t. Then subtract 1 from here, that's half. Now, times, what's the differential of 1 minus t? The differential of 1 minus t is minus 1. So multiply by minus 1. So that means our dy dt now is equals to minus 3 over 2 minus 3 over 2 square root of 1 minus t. Let's do for z. Our z is what? Our z is 3 t 3 raised to power 2. So that will be, our z will now be equal to 3 times 3 over 2 t. Subtract 1 from here, that's half. That means our dz dt, sorry, dz dt. So our dz dt is equals to 9 over 2 square root of t. So we know our dx dt, we know our dy dt, and we know our dz dt. So I'm going to take all of this off and insert it inside this equation. So let's do that. So now that means our L be equals to the square root of, no, integral from, not square root, integral from a. What's our a? Our a is the initial position, which is 0, to the final position, which is t. Then square root of the s dt square. What are the s dt? We got the s dt, if you remember, 3 over 2 square root of 1 plus t all square, plus dy dt. We got dy dt to be equals to minus 3 over 2 minus 3 over 2 square root of 1 minus t all square. Then our dz dt, we got it to be plus 9 over 2 square root of t all square. Then dt. Let's open these brackets. Our L now, because to the integral from 0 to t, the root of 3 over 2 all square is 9 over 4. So 9 over 4. If we take the square root of this, that will be 1 plus t. Then minus 3 over 2 all square will be 9 over 4 also. If we take the square root of this, that will be 1 minus t. Then plus, this will be 9 over 2 all square is 81 over 4. Then the square root of t square is t dt. So let's rearrange this. L now, because the integral from 0 to t of square root of 9 over 4 plus 9 over 4t, this way, plus another 9 over 4, then minus 9 over 4t, then plus 81 over 4t, then dt. If you arrange this, your L now, because the integral from 0 to t, 9 over 4 plus 9 over 4, that will be 18 over 4. 9 over 4 plus 9 over 4, 18 over 4. 9 over 4 minus 9 over 4t, that's 0. Then you have plus 81 over 4t dt. So if you arrange this, that will be integral from 0 to t of square root of 18 plus 81t over 4 dt. So this is our L. This is our L after rearranging. This is what we got for our L. This is what we need to integrate. So to do that, let me take away all of this and write our L. So we got our L after analyzing all of this to be equals to L is equals to integral from 0 to t of root of 18 plus 81t over 4. We can rearrange this also to be integral from 0 to t of the root of 18 over 81t divided by the root of 4, which is 2 dt. So our L is what? Our L is 10 to be equals to integral from 0 to t of 1 over 2. This is 1 over 2 root 18 plus 81t dt. This can come in, that's 20 equals to integral from 0 to t of root 18 plus 81t dt. So this is what we need to now integrate. To integrate this, you can use any method that you know to integrate this. But I'm going to use this method. I'll let u to be equals to 18 plus 81t. I'm changing the variable from t to u. So let u equals 18 plus 81t. This changing variable. So that means my du dt now will be equals to, if I differentiate u now, I'm going to have 81. So I don't want to have dt here again. So I'll make dt the solution formula here. So that means my dt now equals to 1 over 81 du. So I'm going to change this dt to 1 over 81 du. So dt is 1 over 81 du. Also, I'll change this to u. So that means I'm going to have 20 to be equals to integral from 0 to t of root u instead of root nt minus this. Then instead of dt, because I've changed the variable to u, I can't differentiate to the t again. It will now be 1 over 81 du. Since 1 over 81 is a constant, I can bring it out. That will be 1 over 81 integral from 0 to t square root of u du. So I can bring this 81 to this side. So that's 20 times 81. That's 1620 to be equals to integral from 0 to t. Square root of u can be written as u raised to power 1 over 2 du. So I can now integrate this. That's 1620 to be equals to u 1 over 2 plus 1 over 1 over 2 plus 1 from 0 to t. So that's 1620 to be equals to u raised to power 3 over 2 divided by 3 over 2 from 0 to t. So I can still bring this 3 over 2 here. 1620 times 3 over 2. That's going to give us 2430 to be equals to u3 over 2 from 0 to t. Now with this, I can bring back my t, my u, and my u is what? 18 plus 81. So that means my 2430 now equals to, instead of u, I'm going to have 18 plus 81t raised to power 3 over 2 from 0 to t. Now I can now apply the indefinite integral method to solve it. So applying definite integral, we're going to have 2430 to be equals to, we are going to put t inside this function as 18 plus 81 capital T raised to power 3 over 2 minus 18 plus, instead of 18t now, that's 0. 81 times 0, which is 0, 3 over 2. That will be 2430 to be equals to 18 plus 81t raised to power 3 over 2 minus 18 raised to power 3 over 2 will give us 76. That should be 76.37. So bring this 76.37 here. That will be 2430 plus 76.30. 76.37. You're going to get 2506.37 to be equals to 18 plus 81t raised to power 3 over 2. Now to solve this, multiply both sides. Okay, square both sides and take the cube root of both sides to remove this 3 over 2. How will you do that? So what we are going to do is that since this is raised to power 3 over 2, so multiply both sides by the power of 2 over 3 to cancel this 3 over 2, because if you multiply this 3 over 2 by 2 over 3, this will turn to 1. So multiply raise both power on both sides by 2 over 3. That will be 25 that will be 2506.37 every raised power 2 over 3 to be equals to 18 plus 81t raised power 3 over 2 now times 2 over 3. The 2 over 3 will cancel this, so this will be left with 1. So press this in your calculator. 2506.37 square, then cube root. So you're going to have 184.514 to be equals to 18 plus 81t. So if we solve this, bring this 18 to this side and divide both sides by 81, your t will be equals to 2.05573. So if we solve this equation, this is what you're going to get. So we know our t that we need. Since we know our t, we can find the sin t. We have to find sin t. And what's t? Our t is 2.05573. Make sure your calculator is in radian. You're going to get 0.8847. So your answer is 0.8847, which is this. So we'll move to lecture 5.